Alright, hey guys. In this video, I want us to go ahead and look at adding, subtracting rational expressions, and remember to rational expressions, they're like fractions. So when we add or subtract them, you must always have to have common denominators. And so we got a few steps here. And step one is broken down in two parts. If the denominators are the same, then we're good. We just add or subtract the numerators, and we place our answer over that common denominator. But a lot of times when we see these, the denominators are going to be different. And when that's the case, just like with regular fractions, we first want to find the LCD, the least common denominator. Once we find that, we want to write each expression so that it has the LCD as its denominator. And then once both fractions or all the fractions have the same denominator, then we just add or subtract the numerators, and then again we place our final answer over that common denominator. And then step two is just like always with fractions, we always want to simplify and make sure our fractions are always in lowest terms. Alright, so let's just go ahead and let's jump right in and start doing some of these examples. Alright, so in our first example here we have 5 over 3x plus 2 over 3x. And if we notice that, we notice that both of the denominators are the same, so they have common denominators, so all we have to do is just add the top. So 5 plus 2 is 7. Common denominator does stay the same, which is just 3x. And so now we just want to see, hey, can I reduce that? And no, you can't. So 7 over 3x, that is our final answer for 5 over 3x plus 2 over 3x. Alright, so let's try another one. Alright, here we have a subtraction problem, but again, the denominators are the same, so we're good to go. So x squared minus 9, we really can't combine those because they're not like terms, so we're just going to write it up together over that same denominator though. So x squared minus 9 over x minus 3. So that was step one. And then step two, we just want to make sure it's in simplified form. Well, if we look, this x squared minus 9, well, that's difference of squares. So we can factor that. And so hopefully we remember that difference of squares, that factors into x plus 3, x minus 3. Then on the bottom we still have the x minus 3. And now, going back to the multiplying and dividing of rational expressions, we know that any common factors cross off, so I can cancel off my x minus 3's. And so we're just left with x plus 3. And so then that would be our final answer. Alright, so I want you to take a few minutes and try the next one for me. Alright, so here's the problem I would like for you to try. So it's 2 over x squared plus x minus 2 plus x over x squared plus x minus 2. So again, just pause the video now, give yourself a few minutes to try, and then you can start the video back up. Alright, so again, if you notice that the denominators are the same, so they're going to be the same in my answer. So I'm going to just combine the tops. I can't add them together because they're unlike terms, but we can just write it up as 1 using that same denominator, x squared plus x minus 2. Alright, and now we just want to see if we can simplify it any more. And I think we can. I think the bottom factors, and if you try to factor the bottom, you would get 2 plus x stays on top. I'm not doing anything with it, but the bottom factors into x plus 2 times x minus 1. So again, we can cross off our common factors, so the x plus 2's are gone. And so we're just left with 1 over x minus 1. And that is our final answer. Alright, so very good. Alright, now let's get into some of these where they are not going to have the same denominator, where they do have different denominators, and so to do that, we're going to first start looking at just finding LCDs. Okay, so we're just going to find LCDs, least common denominators. All right. So when we're looking for common LCDs, or the least common denominator, it becomes pretty simple to find these. Here we have 5xy squared and 2x cubed y, and we just want to find the LCD between these two. And so when you find the LCDs, you first want to make sure everything's factored completely, and if we notice, these two numbers are. Alright, so now we just want to try to find what they have in common. So we're just going to start with the number. So 5 and 2. So let's think, what's the smallest number that 5 and 2 will both go into. And so that number just happens to be 10. All right, so we got 10. And so we're forming the LCD now. And so now we have 1x. One of these has 1x, one of them has 3 x's. So what's the smallest number of x's that both of these will go into? Well, obviously 1x would go into 1x, but then I couldn't take 3 x's and put that into 1. So the smallest number that both an x and an x cubed would both go into is actually x cubed itself. X goes into x cubed, and x cubed goes into x cubed, and so that becomes the x part of my LCD. And so then with the same concept of y, one has 2 y's, one has 1, so the smallest amount that we can use is the 2 y's. And so my LCD just becomes 10x cubed y squared. Remember, it's not the smallest number that will go into our numbers, it's the smallest number that our numbers will go into. Alright, so let's try another LCD problem. Alright, so here we're asked to find the LCD of y squared minus 2y minus 8 and y squared plus 3y plus 2. Again, our first step is we want to take each one of these and we want to make sure each one is in factored form. So the y squared minus 2y minus 8, well, that factors into y minus 4, y plus 2. And then the y squared plus 3y plus 2 factors into y plus 2 and y plus 1. Alright, so we have them each factored, and so once you got all your polynomials factored, finding the LCD is kind of easy. You're just going to start with either one of these, but start with either denominator, and you just write down your 2 factors. So I'm just going to start with the y plus 2 and the y plus 1. Okay, so those are 2 of my factors in my common denominator. So now I go over to my second polynomial, and if we look, well, the first one we see is y minus 4, and if we look down here, okay, if we look down here at the LCD, okay, do I already have a y minus 4 there? No, we don't, so we gotta also include a y minus 4. Alright, and then we go to the next factor. We see over here. Okay, we see over here we have y plus 2, and if you notice, we already have a y plus 2 here, so I don't need to add another one, and so my LCD is set and ready, and it's just y plus 2 times y plus 1 times y minus 4. We cover all the denominators of our 2 polynomials, and so that is my LCD, and so that's pretty much it for finding LCD. You just make sure everything's factored, start with what's given to you, and then start with the first one, and then if there's something in the second one that you don't already have, just include it as well, and then that's your LCD. Alright, so now that we know how to find LCD, now let's go add and subtract rational expressions that have these different denominators. Alright, start off with kind of an easier one. So here we have 5 over 2p plus 3 over 8p, and so now if we just look, they're both pretty much factored, and so if we look, my LCD of 2p and 8p just becomes 8p, and so that's the smallest number that 2p and 8p both go into. And so now we already have our second one is over 8p, so I'm going to keep it over 8p. I'm not going to do anything with it, but instead of 5 over 2p, now I want something over 8p. Alright, so that gives me something over 8p. And now what times 2p can get me to 8p? Well, that is 4. And so we also got to multiply this 5 by 4, and so that gives me 20. So 5 over 2p is equivalent to 20 over 8p. But now we notice that they have the same common denominator. And so we're ready to just add these together, where 8p is my common denominator, my answer. And then 20 plus 3, well, that's just 23. And now you got to say, hey, can I simplify that any further? And no, we can't. There's no common factor between 23 and 8, and so that becomes my final answer. Alright, so now that we kind of done an easier problem, now let's start picking it up and getting it maybe to some of the harder problems. Alright, so here we have 3 over x minus 6 over x minus 5. And so, again, first step is we want to make sure all denominators are factored, and they are here. And so now we can just write up my LCD. So we look at the first one, and we see it's just x. Okay, and so then we look at the second one, and then it's x minus 5. But if you look at your LCD already, you don't have an x minus 5, so you got to include an x minus 5. And so that becomes your LCD. Alright? And so now we just need to take each fraction we have and write it over the LCD. So I got 3 over x times x minus 5, but I didn't originally have the x minus 5 there. I had to multiply it to the bottom, so that means we also have to multiply it to the top. And then if we look at the 6, well, it was missing just the x by itself. So if I multiply the x on the bottom, then I multiply the x on the top. And so we wind up getting 6x. But now we do have that common denominator, and so I'm going to combine everything. And so first I'm going to distribute my 3 through. And so what we wind up getting is we wind up getting 3x minus 15 minus 6x. And now all that's over that same common denominator of x times x minus 5. Okay. And now I see we have like terms on the top, so we can combine and clean up a little more. So 3x minus 6x, well that's negative 3x minus 15 over x times x minus 5. And it just glancing at it, it looks like, hey, I may be able to factor something. And so the only thing really you can take out of the top is a negative 3. And so if you take a negative 3 out, you're left with x plus 5 now, because you took the negative out, over x times x minus 5. And now if you notice that you actually could not factor anything else out, and so either one of these two answers is acceptable. So you could either have you could have left your answer in this form here, or you could have just factored out the negative 3 and got this answer. But again, either answer would have been acceptable on a quiz or test or anything.